Okay, hello everyone. So many people. And my name is Belov, and I work at JetBrains. And at JetBrains, I wear multiple hats. So I'm responsible for our innovation incubator, everything which is about Kotlin and AI. And I was the one who actually came up with the idea of Kotlin Notebooks. And outside of JetBrains, I also wear multiple hats, and my favorite one is this one. And when I put it on, I'm not an ordinary man anymore. I'm a sailor, I'm a skipper and captain. And I'm really fond of sailing, really. And I love recreational sailing, and I love competitive sailing. Who has sailing experience? So many people, it's amazing. So for others, simple explanation, like what is a sailing race? You start at some point, then you go point by point, and then you have to finish and cross the finish line, the first one. And but 2 years ago, I participated in a completely different thing. And it's called 24 hours race. And it's let me explain how it actually, the rules of this race. So it takes place in the Netherlands. And the idea is following. You have 24 hours, and you need to sail the longest road. The problem is that you can't sail everywhere. You have to sail only along some predefined roads. And the biggest issue is that you can sail each segment only 2 times. So you can't do it like this. And yeah, so there is a map. There are a number of black segments which are ordinary segments, and also a few red roads which are the entry roads. You can sail them once. And there's one green one in the middle, and it's actually finish one. So there is some finish line as well. So, and at that moment I said, obviously, say no more. I need to code it because it's so hard. I'm put off this hat now. And let's try to do it, obviously, using Kotlin Notebooks. OK, so in Kotlin Notebooks now, you can create a new notebook simply from the welcome screen. So I will create one here in folder. I'm going to change the folder and to this one. And yeah, let's call it this way, and create. Here we are. Now we have a new notebook. Actually, I have some files in this folder as well because I practiced. And yep, so yeah, there are some of them. Anyway, let's start working. So first, I will pull a number of libraries. And in notebooks, we have option to pull it from Maven Centron, and we have also a number of shortcuts for the most popular libraries, like Cater or Candy. It's our library for plotting, and Candy Geo is for plotting geography stuff. So it will automatically download it, and let's go to their website and take a look actually what information they can provide. And fortunately, there are waypoints. That's great. So we can download it as Excel file or GPX. GPX, it's GPS exchange file. Basically, I like it because it can be converted to GeoJSON, which is more standard file for plotting and carrying geography stuff. So, and I will just take this converted version and drag and drop it into our notebooks. And voila, we're done. We actually already have our data. But now we, of course, want to plot it, so verify that we do it correctly. So I will plot it and put it geo points. Here we are. Oh, I'm not sure. So let's find some map. And for this, like you can take any other open GeoJSON. By the way, they are supported by GitHub and render it nicely. So like you can like put it on top of probably Google Maps or something. So let's copy the link address of this GeoJSON and read it. So like let's take a geography data frame, read JSON, and put it here. Great, now I have this map, and I can as well plot it, but not its geo map thing. Great, that's exactly what I want. Let's apply some styles. So let's recolor the polygons. Let's change the background and size. And yeah, now we want to draw the points, obviously. So, and like you can add layers on top of this. So for instance, it's going to be with data, our points data, and geo points like we did it before. And let's add them some color. Great, that's exactly what I want. But like the framing is wrong, right? So let's add some limits. You can actually find the limits like looking at the map, but like I will do it like probably this way. So like implement some variables and apply them here. And here we are. That's pretty similar to what we have before. So now we need to get the data about the roads. Okay, let's go back to the website. And on the website, there are, let me check, where is the info? There is like Rakon overview, which is roads overview. And it can be downloaded as Excel. I, of course, downloaded it. And it looks terrible because it's Excel. So first of all, they have two data frames here, like one for starting roads and one for ordinary roads, and they put it all together, which is weird, but like let's tackle it. So I will drag and drop it here. Obviously, everything is broken because like it's pretty strange one. So, but I can, for example, skip the first row, which was junk row, and take just a number of 13. Yeah. So I will, oh, no, wrong one. And take rows count 13. Yeah, now it's better. And now I will concat it with the rest of this data frame. So like I just copy and, oh. And you know what is it? It's a famous freeze. Funny enough that sometimes it helps just to put out HDMI. And you know what is it? It works. So, where we were, like here, right. So concat with the stuff that was here. Oh, I actually, and you know what is it? It's famous freeze. No, it's really weird, to be honest. Okay, so now it works. So, and hopefully somebody from Kotlin QA here. Yeah, so we now got the proper data frame, hopefully. Yeah, great. So, and I will apply some post-processing on top of it. Because like I don't like a few things here. So like I don't like naming. This column wasn't parsed, and there is some junk column in the end. And I also want to add ID in. And something wrong with locale. Let's import it from Java. Great. So we got it. And we now can couple it with some geography data. So I basically created a map of points and created these segments here, like as a geometry column. Now we have segments. And yeah, let's draw them. So with data segments. Oh, basically it was correct suggestion. Great. And yep, we did it. And let's probably apply some semantic coloring. So for example, by number of maximum passing times. So, and scale in this case should be categorical. Great, that's exactly what I wanted. So next, let's pull wind data. And for this, I will use forecast from Open Meteor using like Cater library, which I've used in the beginning. So, and cool story is that like it returns some JSON, but if I like put it like this way, and I say deserialize JSON, then forecast gonna look the same, but it now typed. So, for example, I can access howler, time, that's it. So, strong vibes of JavaScript, right? So, and yeah, let's now define some function that gonna like do this stuff for me. So, forecast function. And you see, like in this forecast function, I actually use this forecast type that was generated based on the original JSON, which is really handy way to implement all this stuff. And now I can play with it. So, for instance, like let's create a grid with the forecast over my map. So forecast 2, and here I need to implement step function. So basically, I'm just iterating with some step over my map and get the forecast. And like it will take approximately 15 seconds, hopefully. And yep, nope. Yeah, I'm not sure like how fast the, oh yeah, 23, great. So if I take this wind now, it's like some weird thing again. So I will convert it to data frame so to see what's inside. And yeah, now it looks way better. And if I scroll, if I manage to get it, oh, something wrong with HTML again. I don't know why. Yeah? Yeah. Sorry for that. Yeah, so now it's scrolled. And there are some nested objects. And cool about Kotlin data frames that it can be nested as well. So like I can use these nested objects as like nested columns. And here we are. Like now we have these columns and like, okay, let's call it file windf. And this windf thing now has the following schema. So with some structure. And it basically means, for example, if I want to draw some forecast on top of my map, I need to repack the structure. And it's really simple to do without adding any additional types. They're going to be added on the fly. So for instance, here, I can do something like this. So I'm going to explode the lists which were like in nested columns. Then I select only columns I need and flatten the data frame. And basically now I get like longitude, latitude, time, and the data I need, which is great. So on top of this, I can actually convert it all to some vector field, just adding some vectors for all the stuff. And basically that's it. So now we can draw it. So like forecast map, that's exactly the map we had. Then on top of that, we have the vector field. On top of the vector field, we can apply some semantic coloring, which is great. And which is really great, I can animate all of this stuff. So for instance, I will iterate through the rows of the data frame, and it's going to be something like this. And I see that like the wind is changing quite a lot. And when the wind is changing, the speed of boat is changing. And sorry, I'm a bit out of time because of all this stuff. Like, are you okay to wait 5 more minutes? Super. So, and let's talk about the boats. So boats have like different speeds, and by different angle of wind and wind speed. So for this, usually folks use polar diagrams. So how to read it? There is an angle of the wind, there is a speed of wind, 1, 2, 3, 4, 5 knots, and it's actually the speed of the boat. Looks terrible. Let's draw it. And for this, I will read the stuff, got exactly the same data frame. Then I will, again, gather it, repack, and basically what I do, gather it's like anti-pivot, right? So I take the column name and put it in one of the columns. And then I group it by wind speed. So now for every wind speed, 1, 2, 3, 4, 5, okay, for 5 nodes, I have for any angle, boat speed. So let's draw it because like otherwise it's impossible to understand. So looks not that great, but let's explain. So for instance, for wind speed 8, the boat, if it's go like the boat looks up. So if you go upwind, you can't go. The speed is 0. If you go completely downwind, the speed is like 4.3. And if you go like this direction, and for example, half wind, it's way faster. So if we want to go the longest road, we have to go somewhere in this sector. So great, we have boat, we have wind, we have information about all the roads, so we can write a solver. And it's going to be the simplest part, because like you know how to write brutes of solvers, right? So just I will create state with current point, time, total sail distance, and used roads. Then I will get the information about the wind in all my points, not on the grid. So, and while it's getting, I will also initialize my solver. It's going to be like time of the start, which is going to be like in few hours. Local daytime for finish, and like the finish node. And then I initialize the states with starting nodes with based on the max until filled number of passes, right? So, and like it's a variable for accumulating the some helper functions. Like for instance, like adding some duration to local time. You know, we can't have nice things in the language for this. And there was a talk 2 years ago. If you haven't seen it, please do. And why we can't have it. And finally, solver. Great, it's pretty big one. I run it. Nope, it doesn't work. What's wrong? Okay, we need boat speed function. So let's also define it. Board speed function. Great. So while it's running, and I'm brave sailor because it depends on the real forecast. It can work pretty long, and I do love live demo. But anyway, like while it's running, let's see what's going on. Very simple. We take the first state, we get the wind direction and all this stuff, and then we iterate through all the adjacent edges, get the ones based on the used roads that we can still sail, and calculate true wind angle to calculate boat speed later. And basically that's it. And then we just create a new state and add it on in the end if its finish time is still smaller than finish time. So it's basically brute force stuff. So, and like, let's interrupt it and see if we have some finishing states already. Great, we have two. And it's amazing because, like, okay, so let's take the finishing state, one of them. Like, I actually want to take the one which is like at least 30 minutes before the finish, otherwise there are going to be penalties, and take the biggest total distance. And then I will take the roads converted to data frame. There are IDs of these roads. And take just ID stuff, match it with the geometry, and finally convert to geo. And finally, we can take this thing and draw on top of our map. So we take road fin draw it, and we, oh gosh, it's so hard to see it, so let's take these segments and change the alpha to, here we are. So here's our winning road. So it basically means that we can go along this road and win the race. So I really welcome you all on board, and thank you.